3-7, solving absolute value inequalities. And for this one, guys, the know it no page just is not going to work for us. So you could use the back where it's blank, but I think actually it would be easier for you if you just pause the video for a sec and grab a sheet of binder paper to put into your notes section of your binder. That'll be the easiest way to do this. And then you just kind of write down what I've written down, moving down the page every time it's a new slide. So if you need to pause to do that, go ahead. And now that we're back here, we're going to write a few things down. First thing I want you to write down on your binder paper, right, now that you've written down the section 3-7, is that inequalities containing absolute value expressions can be rewritten as compound inequalities. That means this lesson is referring back to yesterday's lesson, or the day before, whatever it was, lesson 3-6, where we were talking about compound inequalities. So let's just think for a moment. You don't have to write this stuff down in blue. Just think with me while you're watching. Think about the absolute value of x is less than 4. What values of x would make this inequality be true? Right, well, a number like 3 would make it be true. Oh, but so would -3. 5, no. 1, that's good. -1, that's fine. So when you think about it, right, if we graphed it, it would look kind of like this in a quick sketch. Right? Anything that was between 0 and 4, well, that would work, right? So if we started here at 4, right, anything going this way, and then also anything between 0 and -4 would work, because those would also have absolute values, right, that were less than 4. That should look really familiar. That's an and graph, right, of, right, -4 is less than x, which is less than 4, or written out, right, with the word and in between, x is greater than -4 and x is less than 4. Okay, so it's turning from an absolute value inequality into a compound inequality. What about absolute value of x is greater than 4? What kind of values would make that be true? Well, 5 would work, 6 would work, 7 would work, a billion would work, right? But so would -10, -12, right? So if we were going to graph it, it would look like an OR inequality. If we started at 4, it would just keep going up forever from there. If we started at -4, it would start there and head down toward -infinity forever. So that's an OR inequality. That should give you kind of the big picture of what we're doing here. Let's start with absolute value inequalities with great or than. This is really an important little mnemonic device. When we have greater than in our inequalities, okay, then we want to turn those into or problems. Okay. The inequality, you're going to write this down. Absolute value of x is greater than a, where a is greater than 0. Ask for values of x that have an absolute value greater than a. So x is less than -a, or x is greater than +a. So we take our absolute value, right, and we turn it into an OR problem. Okay? Notice one problem looks just like the absolute value part minus the absolute value bars. The other one flips the symbol and flips the sign. Okay, so one is as is without the absolute value bars. The other one, flip the symbol, flip the sign. And we'll go through these steps again in just a moment. Right? Visually, this is what we were just showing on the previous page too. You can write it down again if you want. Right? That if absolute value of x is greater than a, this is what the picture is going to look like. It's going to be an OR inequality. Maybe it's going to go to the next page. Okay, so here's the steps. Write them down. If I go too fast, pause it and write them down. Step 1. get the absolute value expression alone, just like you did in chapter 2. A lot of you weren't so good at this part in chapter 2. You wanted to just go ahead and just take the absolute value bars off and just proceed. You cannot do that. You got to get the absolute value part all by itself first on one side of the inequality. Step 2, set up two inequalities separated by or. Let's just take a really quick basic problem here. Absolute value of x plus 2 is, let's do this, 4 plus the absolute value of x plus 2 is greater than 7, right? So the first step there would have been to subtract 4 from each side. Okay, and so now we have absolute value of x plus 2 is greater than 3. Okay? So the first step we already got done. Step 2, we write ours two inequalities separated by or. The first one with less than the negative value. So that would be x plus 2 less than the negative value, right? Or, right, second part here, second one with greater than the positive value. That's the one that looks exactly the same as the problem does, but it doesn't have absolute value bars. Okay. Step 3, solve them. Okay, subtract 2, we get x is less than negative 5. Subtract 2, we get x is greater than 1. And then graph them. Right? I'm not going to do that part right here because I know you know how to do that. We'll do it on the next example. Make sure you write your final answer with the word or in between. X is less than negative 5 or x is greater than 1. Now we'll have another example. This one you can try it yourself. You can pause the video and give it a shot. Here it is. Absolute value of x plus 14 is greater than 19. Don't forget to get the absolute value part all by itself. Okay, now that you're back with me, right, we're subtracting 14 from each side, so we get x, absolute value of x is greater than 5. Oh, well, there's nothing else to do because x is already all by itself. So we've pretty much finished it. Now we just have to write our two inequalities. So the first one is less than the negative, right? So I flip the sign, right, to get less than, and I make the number negative. Okay. And maybe flipping is not a good place to write it there. Some of you will get confused and think you have to flip it again. All right, or x is greater than 5. So we don't do anything to the number. We don't do anything to the sign on the second one. All we do is take the absolute value bars off and then graph it. Greater than 5, less than negative 5, and we're good to go. One more example because I love you and I want you to really understand this. Pause the video and try it. Don't forget to get rid of the 3 first. We're back. We're subtracting 3 from each side, okay, which gives you the absolute value of x plus 2 is greater than 5. And now we write our two inequalities. The first one is the flip one. So x plus 2, flip, becomes less than negative 5. The other one, we just do it as is, no absolute value bars. Solve, x is greater than 3, x is less than negative 7, put that or back in there, and graph it. Greater than 3, less than negative 7, done. On to less than problems. When they have less than, okay, I'm going to write this down. I know it's a lot of writing today. The inequality, the absolute value of x is less than a. Okay, ask for values, right, that have an absolute value of x less than a, right? If you can read the algebra, you can write the words. It's the same thing. Okay? And so that turns into an and inequality, where x is greater than the negative of a and less than the positive. So again, look at the pattern here. X is less than a, absolute value of x is less than a, turns into plain x is less than a. The other one flips the symbol and flips the sign. It's the same both times. It results in a different inequality, but they're both formed by flipping the sign of the number and reversing the inequality. And this is where we end up with the between one, right? Because it's greater than negative a and less than positive a, an and inequality. This is the last big writing, I promise. The steps for less than, you'll be so grateful you have these. This is one of those things that people always struggle with when we come back to it later in the year studying it for STAR testing. So and midterms and things like that. So you'll want to come back and be able to look at these again. Step 1, pause when necessary. Get absolute value expression alone, just like in chapter 2. Step 2, set up two inequalities separated by and. The first one has greater than the negative value. The second one has less than the positive value. So if I had a really simple one, like x plus 3, absolute value, is less than 5, that means my two inequalities are x plus 3 greater than the negative, and x plus 3 less than positive. Notice the second one is exactly the problem, right? And with no absolute value bars, the first one is the flip, right? Flip the symbol, flip the sign. Solve each of those inequalities, and then graph the overlap. We've got 2 examples on this, and then we're done. 4 times the absolute value of x is less than 24. Let's do this one together since it's the first one you've done. Divide both sides by 4 to get the absolute value alone. No distributing. And we get absolute value is less than 6. So for the first inequality, we flip the symbol to make it greater than, and we flip the sign on the number. And, right, the second inequality, we just leave exactly as is from the problem here, and we take off the absolute value bars. So x is greater than negative 6, and x is less than positive 6. Connect them with a line. If it helps you still to draw the 2 so that you can kind of see it first, you can do that, and then you can draw the line between them afterwards. Now this one I want you to try all by yourself. So write the problem down and then pause it. Back here. Now notice the absolute value part's already all by itself. That means I can just jump right into writing my 2 equations because there's nothing, or 2 inequalities, because there's nothing I need to take away from both sides, nothing I need to divide both sides. I'm ready just to write my inequalities. So I get x minus 1, flip the symbol, flip the sign, and the second one is exactly the same, just without the absolute value bars. So x minus 1 is less than 2. Add 1 to both sides to solve it. And that gives me x is greater than negative 1. And, right, x is less than 3. I can rewrite that as a single compound inequality. Okay, so x is greater than 1 and x is less than 3. Open dot on negative 1, arrow to the right. Open dot on positive 3, arrow to the left. So we're looking at the in-between of those. And I think that might be it. That's it. It's your lucky day. See you tomorrow. We'll go over more examples, I promise.